Hi, and welcome to What's NASA Done for You Lately? I'm Dr. Ann, scientist, education specialist, Earth citizen. My goal in this series is to show you the many ways NASA and science serve you and society. Most people know NASA launches rockets. Not everyone knows what else NASA does with your taxpayer dollars.
When I made this recording, 35 earthquakes had already occurred worldwide within the previous 24 hours. All were Richter scale magnitude 6.0 or less, which often are felt but usually cause minimal damage. In contrast, magnitude 7.0 or greater earthquakes, like the 7.7 event that struck March 28th in Myanmar, occur approximately 15 to 16 times a year. I have only ever experienced one directly, the magnitude 7.1 Hector mine earthquake that struck Southern California, but which I felt in Phoenix, Arizona, more than 300 miles away on October 16, 1999. Unfortunately, the March 2025 Myanmar strike-slip earthquake struck a heavily populated, war-torn area with vulnerable cultural treasures and other infrastructure, leading to a significant loss of life. In the immediate aftermath of a powerful earthquake and its aftershocks, knowledge and time are two valuable assets in the race to rescue people and survey structural integrity. With NASA's Advanced Rapid Imaging and Analysis, or ARIA team, geodesy data products can aid in assessing tectonic plate displacement and deformation, crucial information that supports emergency responders deployed during these natural disasters. Combining satellite remote imaging and ground-based observations, the ARIA team develops methods and models for quickly processing these large data sets. As the initial crisis passes, ARIA's data products can also be used by seismologists to advance our understanding of earthquake processes and types. To illustrate, ARIA's work on the Myanmar event revealed that it may have been a rare super shear strike-slip earthquake in which seismic energy along the fault is concentrated before the rupture, due to the slip moving faster than the resulting seismic waves, greatly magnifying subsequent destructive forces. If you live in an earthquake-prone zone, you likely benefit from NASA technology whether you realize it or not. First, NASA's Jet Propulsion Laboratory in Pasadena, California, pioneered research into technology that could use standard smartphone sensors as a basis for early warning systems. Apps, including MyShake, created by the University of California at Berkeley, and QuakeFeed, now rely on that research, utilizing accelerometer data from your and other people's smartphones to detect ground motion and trigger earthquake alerts. The citizen science network can be especially helpful in earthquake-prone areas around the world, like Myanmar, that may not have well-established seismic monitoring capabilities. Second, during an earthquake, fluidic-based seismic dampers, which were originally developed by North Tonawanda, New York-based Taylor Devices for launch pad operations during NASA's Apollo and Space Shuttle programs, absorb seismic energy, significantly reducing damage as well as the risk of building or bridge collapse. Finally, NASA AI-enabled drone technology enhances human disaster responses by providing mobile communication networks, high-resolution imagery, and critical real-time data in the search for survivors. These uncrewed aerial systems can carry finder units, which utilize microwave radar to detect heartbeats and breathing from individuals trapped far deeper under rubble and far quicker than traditional search and rescue techniques with specially trained dogs. While this episode focused on earthquakes, ARIA and these spin-off technologies can also be applied to other natural and man-made disasters.
From my time at Arizona State University to now as a NASA education specialist, I've been most struck by the disconnect between what we do in research settings and what we educators teach our children, and by extension the public. To borrow from Dr. Neil deGrasse Tyson, people think science literacy is reciting facts. It's a part of it, but science and math influence your health and safety and what it means ultimately to be alive. The greatest joy from my NASA webinars a few years back was helping people make the connection between NASA research and its benefit to them here on Earth. This series builds on that legacy. Thank you for listening. I truly hope you've enjoyed this episode.